Today we are going to start graphing. Yay! All right, so the basic concept of a graph is as shown here, where we have the y-axis that goes up and down, the x-axis that goes left to right. We have four quadrants. There's quadrant 1, and going counterclockwise, we have quadrant 2, and down quadrant 3 and quadrant 4. So, where does this start? Your graph starts at the origin, which is the center of your graph right there. Oh, let me get some color here. The origin, you would go, if we put an origin in an ordered pair, when you go to the left of that point, your numbers are negative. When you go to the right of that point, your numbers are positive, just like on a number line. So, if the next number in your ordered pair would be y. If you go up, it's a positive number. If you go down from that origin, it's a negative number. The way that I remember this in math, every time something goes up, it's positive. Think about it. Every time in life, when things go up, they're positive. Like you go to a party and there's a lot of people, you're like, yeah, that's right, there's a lot of people, it's positive. If you go to that same party and there's only one person, that's a low number, so that's negative, so that's down. So think about your bank account. If you have a lot of money, you're positive. Hey! If you don't have a lot of money, that's pretty negative. Especially if it's negative, then it's really negative in your bank account. So all numbers, when you go up, it's positive, and when you go down, it's negative from that point. So if I were to do an ordered pair for the origin, I would start at 0 on my x and 0 on my y. I would not move from that spot. So the origin is 0, 0. So we're going to graph the following ordered pairs. I'm going to make a little mental note that that's my x followed by my y. My x tells me I'm going to go to the left 3, and my y then tells me I'm going to go up 5. There should only be one point on your graph. So you don't want to go left 3, put a dot, and then go up 5, put a dot, because then you'll have 2 dots. But that ordered pair just represents 1 dot on your graph. If you were to start here at 0, 0 and go backwards 3, 1, 2, 3 because it's negative, and up 5, 1, 2, 3, 4, 5 because it's positive, there would be your point. It would be negative 3, 5. Now keep in mind, when you do this, when you start at 0, this is 0. It's not 1, 2, 3. When you lift your pen off of the 0, 0, then it becomes a 1 the next box. So if I were to ask you what quadrant that would be in, we recall that this would be quadrant 1, so this is quadrant 2. When you have 6, 4, you still have your x, comma, and then your y. Your x would be going to the right because it's positive, and then your y would make that go down 4 because it's negative. Remember that x is here, y is here. So we're going to start at 0, 0 and go over 6. 1, 2, 3, 4, 5, 6. And then from there we're going to go down 4. 1, 2, 3, 4. And put your dot, and we'll label it 6, negative 4. And again, if I were to ask what quadrant that was in, you would start here at 1 and go counterclockwise. 2, 3, that would be quadrant 4. The next one would be negative 6, negative 6. So it would be x, comma, y. And with your x, you're going to go negative 6, and then y, you're going to go negative 6. So you start at 0, 0, and you go to the left 6. 1, 2, 3, 4, 5, 6, and down 6. 1, 2, 3, 4, 5, 6. And that would be your point, negative 6, negative 6. And then again, it would be quadrant 1, 2, 3. Quadrant 3 would be quadrant 3. This is bugging me, so I'm going to do this for 2. The last thing here is the point is 2, 3. So you have x would be 2 and y would be 3. It would be positive, positive. So I'm going to go in the positive direction on my x and a positive direction on my y. Starting from 0, 0, I'm going to go positive 2. up 3, and there's my point, 2, 3. And then if I were asked what quadrant that's in, it's in the very first quadrant, or 1. Awesome. So that's the basics to graphing. Determine whether each ordered pair is a solution to the equation x minus 2y equals 6. When I first look at directions, I'm like, man, I'm not given much, but then I am. A says 6, 0, and I'm like, how can I fit that in there? Well, if I have 6 is my x, and I remember that 0 would be my y in an ordered pair, then for my x I'm going to put 6, and for my y I'm going to put 0. So I would have 6 minus 2 times 0 equals 6. And then I would complete it with my math. 6 minus 0 is 6, and there we go, 6 equals 6. So this would be yes, it is an ordered pair. It is a solution. That means that that point falls on that line. Should I graph that line? 6, 0 would be on that line. Let's try the other one. If I have x is 2 and y is 3, for x I'm going to put 2, and for y I'm going to put 3. So I have 2 minus 2 times 3 equals 6. So I have 2 minus 6 equals 6. Negative 4 equals 6. Negative 4 does not equal 6, so this would be not a solution. It just means that on the line, x minus 2y equals 6, the point 2, 3 does not fit on that line. Here, if we complete the table for the equation, 3x plus 5y equals 9. The table gives you values for x's, and it gives you values for y's. So if it gives you a value for x, you're going to substitute that variable in for the x and solve for y. This is pretty cool because if we have 3 times 0 plus 5y equals 9, anything times 0 is 0, so I'm just going to cover this up, not count it at all, and I just have 5y equals 9. When I divide by 5, I get y equals 9 over 5. If I want to put that into a decimal, I can, and it would be y equals 1.8. So when x equals 0, y equals 1.8. And you're like, wait a minute, is that possible? Can y be a decimal? Absolutely. Not every single place on the graph will cross at an intersection of a whole number. So you can have a fraction or a decimal answer. So then I move on, and if I get y equals 0, I'm going to put 0 in for that y. So I have 3x plus 5 times 0 equals 9. And again, I have that anything times 0 is 0. So I can cross that out. And I just solve for x. So I just divide by 3, and I get x equals 3. So another point on that graph of that line would be 3, 0. Last but not least, if we say y equals 3, then we put 3 in for y, and we have 3x plus 5 times 3 equals 9. Now I can't just cross it off because it's not a 0, so I have to do the algebra. 3x plus 15 equals 9. I have to get x by itself, so I'm going to take 15 to the other side. And I have 3x equals negative 6. And when I divide by 3, I get x equals negative 2. So if I were to have to graph these 2 points, I would actually graph the 2 ones with the whole numbers, because that would be easiest. Let's talk about slope. Ooh, let's talk about slope. What do we know about slope? Well, we know that slope is rate of change. It's the rate at which the line is changing, the steepness of a line. So So if I were to go skiing and my slope was like this versus like this versus like this, then in order to gauge the height of that slope, I would go along an imaginary x line, an imaginary y line. This would be my x, this would be my y. So here I would have to go down, and then I would have to go over. If I were to do this one, I would have to go down and then over. If I were to compare this line, I would have to go up and then over to get to the steepness of my line. So that would mean that I would give you my change in my x values. I would go up or down, and then I'm always going to go to the right. I always read my graphs from left to right. It's just easier that way for me. Now, if you look here, if you go up, your slope is going to be positive. If you go down, your slope is going to be negative, and you're always going to go to the right. So the bottom number we're going to just keep as a positive. If you go up or down, you're going along the y-axis. So this represents change. So instead of writing the word change every time, I'm just going to write the delta sign. So I have my change in my y values over the change in my x values. I'm going to go up or down, and then I'm going to go to the right. If I would look at these slopes, if I were to go up and to the right, you notice when I go up it's positive, and look, that slope is positive. What? If I were to go from this point to this point, I would go down, which would make it a negative slope. Here, I don't go up or down, I just go straight across, and my incline is 0. If you think about walking on a treadmill, you want your incline to be 0, right? So your incline for the ground or walking is 0. Versus you can't walk on walls unless you're Spider-Man. And if you were Spider-Man and walked on walls, that would be an undefined slope. So this right here is slope man, because if you have a positive slope, you're going up. If you have a negative slope, you're going down. If you have an undefined slope, oh, catch the boogies, or undefined, or a 0 slope. What? And there's my slope man. Dun dun dun. Hey. Slope man. I know, it's pretty cool, right? I love it. All right. There are 3 ways to find a slope. Finding a slope using a graph would be the first way that I'm going to show you. I'm going to show you, always read the graph from left to right. So I'm reading the graph from left to right. Here's my first point, and here's my second point. So if I'm reading the graph from left to right, I'm starting at this point, and I'm going to this point. And I'm going to do my change of my y's over my change in my x's. So I'm going to go up or down, and then I'm going to go to the right. So I'm reading from left to right, so I'm reading from this point to this point. I'm going to go down. In order to get to that, I have to go down 1 and over 3. So down 1 over 3. So since I go down 1 and over 3, it's going to be a negative 1 over 3. So my slope of that line would be negative 1/3. At any point in the video, you can stop it, and you can try them yourself, and then come back and see if you have the same slopes that I got. So on number 2, for example, I'm reading the graph from left to right. So that means that I'm reading it from this point to this point, which means that I need to do my change in my y's over the change in my x's. My change in my y's, I would have to go up first. And when I go up 1, 2, 3, and then I go over 1. So if I go up 3 over 1, my slope would be 3 over 1, which is just 3. All right. On the next one, I'm going to read the graph from left to right. So I'm going to go from this dot to this dot, which means I start here and I have to go down in order to get to the next point. And that means I have to go down. Remember, this counts as 0, and I'm going to count it 1, 2, 3. So I'm going to go down 3. And from this point, this starts at 0 again. I'm going to go over 1, 2. So it's the change in my y's over the change in my x's. So it would be down 3 over 1, which would make it a negative 3 over 1, which would be negative 3. Oh, wait, over 2. My bad. Whoop, whoop, whoop. Shoo. All right, the next one, I'm going to go from this point to this point. So that means I'm going to start here and then go up and over. So I'm going to go up 1, 2, 3, and then over 2. So my slope would be 3 over 2, which would be just 3 over 2. For number 5, I'm reading my graph from left to right, so I'm going to go from here to here. So I'm going to go up 1, 2, 3, 4, 5, over 1, 2, 3. So my slope is up 5 over 3, so it's 5/3. Number 6, I'm going to read my graph from left to right, so I'm going to go from here to here, and that means I'm going to go up 1, 2, 3, 4, 5, 6, 7, and over 1, 2, 3. So it's up 7 over 3, so my slope would be 7 over 3. Number 7, I'm going to read my graph from left to right. Oh, so I'm going to go from here. I'm going to go from here to here, which means I'm going to go down 1, 2, 3, 4, 5, 6, and over 2. So it's going to go down 6 over 2, negative 6 over 2. If I reduce that, it would mean that I go negative 3 over 2. Number 3 over 1. And if that's true, then that means that I could go down 3, 1, 2, 3, and over 1. Oh, look at that. The slope actually is negative 3 over 1 also. So we want to get the slope into lowest terms, so it would just be negative 3. What? But we checked our work to make sure that we actually counted right, which is great. And last but not least, I'm reading the graph from left to right, so I'm going from here to here. So I'm going from here, and I'm going to go up 1, 2, 3, 4, 5, 6, 7. And I'm going to go over 1, 2, 3. So it would be up 7 over 3. So my slope would be 7 over 3. Awesome. So a lot of times I see these done and I see that you move from right to left. I just don't do it. Because sometimes then I might put the bottom number, the change in my x's, on top. And if you want to get technical, I do have a story for you to remember that it goes change of y over change of x instead of. So in other words, why do we do change of y over change of x versus change of x over change of y? I have a great story for you. So this is the reason why we have to put y on top. Because x and y were playing at the window one day. I'm an artist. Didn't know if you knew that. Here's my window. Whoop, whoop. Those are curtains, in case you didn't know it was a window. And x and y were playing outside one day, and x fell out the window. But guess what? Y was there to save him! Oh! Because if you think about it, if this was our window, and y fell out, x would be like, bye, and y would fall. Meh. That would be so sad. So sad. But now, y has to go on top, because then it can be a bright, sunshiny day. Yay! Sunglasses on my son. Hey. Yay! So y always has to go on top to catch x. In case you didn't know why. Now you do. All right. So there's finding graph, there's finding slope using a graph. The other part is using 2 points. So if we find the slope using 2 points, we're going to do the change of our x values, change of our y values. Look at that, I already made that mistake. Change of my y values over the change of my x. See, y is saving x. Hey. So that means that we are given 2 points, say this point and this point. We're given this point, and there's an x value and a y value. We're given this point, and there's an x value and there's a y value. I cannot say that those x's are the same, because one's a 5 and one's a 7. And I can't say those y's are the same, because one's a 4 and one's a 9. However, if I put them into an equation together, I'm implying that they are the same number. So I'm going to say that this is my first point, and this is my second point. So therefore, this is my first x and my first y value, and this is my second x and my second y value. So those subscripts on the letters would just mean that there were 2 different points that we're talking about. So my change in y, and actually you've always learned it as y2 minus y1 over x2 minus x1. I'm going to teach you something amazing, actually. When I found this out, I was like, what? Why in the world was I taught it that way the whole time? So this is what I want to teach you. If I changed point 1 and point 2 around on my paper, so I put 7, 9 first, and then 5, 4 second, then my point 1 and point 2 would be different. And then if I change them around and I don't even know what I'm trying to say here, but I do know this. When I go backwards, 2 minus 2, 1 minus, I always mess up. But I want to tell you something. You can change this formula to y1 minus y2 over x1 minus x2. It will not change the value of your numbers in the end, just so you know. So whether you use the first version, which you've been taught since 6th grade probably, or you learn the second version, which you probably haven't seen until right now, you're going to get the same number. The only difference is your negative will be on a different spot. But remember, if your negative is in the top, the whole thing's negative. If the number is in the bottom negative, it's going to be, the whole thing is negative. So it doesn't matter where that negative sign falls. I'm going to do it the green way. You can do it the red way if you choose. I'm not trying to change your way. I'm just trying to make it easier for you. So here I go, and I'm going to do my y minus y. So I'm going to go 4 minus 9, because that's the change in my y's, over the change in my x's. My x's would be 5. These are on bottom, so 5 minus 7. So I'm going to get negative 5 over negative 2. When I have 2 negatives, it equals a positive, so I have to change that to a positive 5 over 2. If you did it the way that you've always been taught and did 9 minus 4 over 7 minus 5, you would have also gotten 5 over 2. So it doesn't matter which way you do this. It's just that I have to think of it differently because I always did it wrong. When I go backwards, my brain just messes up too many times. So I'm going to always do it forwards for myself. So change of my y over my change of my x's. Go ahead and try the next 4. Pause the tape if you want, and then come back and see if you got them right. Okay, I'm going to go on. So I'm going to do 8 minus negative 7 over negative 4 minus 3. Remember, minus negative would really be 8 plus 7 over negative 7. So this would be 15 over negative 7 or negative 15 over 7. It does not matter which way you write it, because as long as the negative is there, the whole thing is negative. Awesome? All right. Moving on to our next one. I'm going to do the change of my y's over the change of my x's. So I have 5 minus negative 7 over 2 minus 2. At this point, I'm going to get a number for the top and 0 for the bottom. Oh no! We'll talk about that in a minute. Let's do the next one, change of my y's over the change of my x's. If I did 6 minus 6 over 5 minus 3, I have 0 over a number. Oh no! The difference in these, if I have 0 over a number, if I have a number over 0, since 0 is under, it's undefined. When 0 is on top, it's 0. So an undefined slope or a 0 slope? Oh no! Let's think about what that looks like. If I were to sketch a graph of those 2 points, I would have 2 5s. So I would go over 2 on my x, up 5 on my y. And I would have 2 negative 7s, so I'd go over 2 on my graph and down 7. So my line would be this. Oh, look at that. In my slope man, the positive slope goes up, the negative slope goes down. Oh, undefined catches the boogies. And look, that's an undefined slope. Thanks, slope man. If I were to do a quick sketch of this graph, I would have 5 6, so I would go over 5 and up 6. And I would go over 3 and up 6. And my graph would look like this. And if we look at slope man, ooh, it's a 0 slope. That is awesome! Cool. All right. The last way we're going to find slope is finding slope using an equation. We're going to make sure the equation is in y equals mx plus b form, because then m is our slope, which is the number attached to x. And if we think about it, then that b is going to be our y-intercept, which is where it crosses the y-axis. So if I give you an equation like 3x minus 2y equals 12. We cannot find the slope, cannot determine slope until the equation is in the right form. So I'm going to solve for y. Which is why we wanted to solve for those unknowns. Because this y has to stay on this side. So I'm just going to drop it. Make sure you drop the negative sign as well. Be mindful of signs. Be mindful of signs. So in order to keep that here, I'm going to take my 3x and move it to the other side. So negative 2y equals negative 3x plus 12. And then y is still not by itself. So I'm going to divide by negative 2. So I get y equals 3 halves x minus 6. Then, now, I know my m is slope which is 3/2, and my b is y-intercept, which is -6. We're going to talk about what y-intercept is after we do this. So we're going to find the slope and y-intercept of a line whose equations are these. Well, this is great because it's already in y equals mx plus b form. Since it's already in this form, then we can say your m is your slope, which is -2. We can say your b is your y-intercept, which is 6. Here we can say y is by itself, so we can say m is 7, and b is -3 because it's not attached to x. C gets a little tricky. Right here there is no b, but I'm going to just put +0 for my b. Because then I can say m is 5 and b is 0. Oh. And on this one, d, y is 3. Then I can say y is, there's no x, so 0x plus 3. So my m is 0, and my b is 3. On E, I can't tell you because this is a negative. Be careful. Oh, no. Be careful. So here I'm going to divide by -1 to get y. Positive. When I divide by -1, I have a positive y equals -5x plus 2. Yay. Now I can tell what the slope is. Now I can say my slope is -5 and my y-intercept is 2. Over here is another, oh no, get y by itself. So in order to get y by itself, I'm going to move x. So -4y equals -3x plus 4. And then it's still not by itself. I have to divide by -4. So y equals 3/4 x minus 1. Yay. Now I can say my m is 3/4, and my b is -1. What? Yay. So now you just learned how to find slope 3 different ways. One by using a graph, one by using the equation, and one by using 2 points.